Hello, Robert and Channel. My name is Ron Story, and I live in Kamloops, British Columbia, Canada. Please accept my submission of the Squirrel fan with ECM motor for the Elegoo competition. The complete unit weighs approximately 9 kilograms, the motor 4.5, and the frame assembly 4.5. In normal operation, the electrically commutated motor, ECM, input is single-phase AC, rectified to DC. It has permanent magnets and is three-phase wound. I've gone through at least 4 versions. Version 1 was a 27-inch bike wheel based on a reaction design. The motor can be credited to Scott Brown's How-To Ceiling Fan Wind Turbine series. Version 2 resulted from using computer fan blades based on other YouTube videos by Daniel Connell, open source low tech. Robert, I came across your video 1447 and like you worked with a direct drive to a stepper motor based on an overshot design. V4 was inspired from Geomorph Dog, who worked with others to develop a Pico hydro system in a 20-liter bucket. All of these led me to the Squirrel fan ECM motor. The trial data from the ECM motor shows an open voltage of up to 43 volts. When loaded, a maximum of 40.4 volts and 28.1 milliamps, which is the equivalent of 1.1 watts, was observed. As measurements were obtained at the beginning of the spring melt, I believe higher flows would provide better results. The squirrel cage assembly is commonly found in metal scrapyards. This unit came with a single-phase motor and a half-inch shaft, not the Project ECM motor. I modified the fan by taking out every second blade, then cutting the whole unit in half with tin snips. I felt too many blades and width might have been slowing down the version 3. Rather than using the existing half-inch metal shaft, I used half-inch wooden dowel, chucked in my drill press, and filed the ends down to allow for a tight fit to attach to the 2 pillow bearings. These bearings would act as the Squirrel fan axle eventually. I had an old 12-inch bike wheel from a previous project which I attached by permanently wiring it in 3 places to the Squirrel fan. The wheel would act as a large drive pulley. This pulley could just as easily have been made out of plywood on the table saw with a simple jig. However, wood has a lesser shelf life in the elements. I used a drill press to create a shallow impression that would accommodate the bearings partially for the uprights. I guessed at the platform size so it would fit snugly into features common to our local creeks. The pulley openings were pre-measured and drilled, then sawed larger with a saber saw. I was careful to mount the wheel with sufficient space between the plywood platform and the top of the modified fan. Again, this was to create the brush shot effect that was required for wheel momentum. Look for an ECM with the heavy mechanical end and the control module or the aluminum hub. Remove the 2 long bolts and remove the control module, carefully unhooking the wire harness inside. I removed the contents of the control module. For testing, give the rotor, which has the permanent magnets, a twist. It should turn fairly easy in cog. Otherwise, check for similar resistance across the windings 1-2, 1-3, and 2-3. You can solder directly into the harness wires. Note the difference in coil wire size between the ceiling fan and ECM. I'm guessing 26 versus 16 gauge. The rotor turns from the shaft on the ECM. However, in the ceiling fan, once magnets are added to the rotor, it's the rotor or fan body, the outside, that moves. It's counterintuitive. I mounted a half-inch variable width pulley I had on the ECM motor shaft, then estimated on the plywood where the belt would travel from the ECM pulley to the Squirrel fan pulley. The belt I used was a half-inch polyester V-belt that can be adjusted to pretty near any length, and they're super durable. The all-found cost for this project was approximately $20 for the squirrel cage assembly and the motor. Everything else I had on hand. Mr. Electron's video nicely explains rectifying three-phase AC to DC. As these motors are a three-phase low-speed generator that just need rectifying, the design might be an attractive alternative for people that don't have many tools and come across an ECM motor but have the desire to build a renewable energy project. Thanks for watching.